we want to talk about how to factor polynomials. Given a product of two linear polynomials, say x plus 2 times x plus 3, we can expand it to get a quadratic polynomial. X times x, x squared, x times 3, 3x, 2 times x, 2x, 2 times 3, 6. So we get x squared plus 5x plus 6. We call this process expanding. On the other hand, how to change a quadratic polynomial to the product of two linear polynomials? Well, it is a little bit tricky, and the process is called factoring. Today, we want to cover a few techniques on factoring polynomials based on the number of terms it has. If the polynomial has two terms, then we try the difference of squares. A squared minus b squared equals a minus b times a plus b. Let's look at example. (144) x squared minus 25. We know 12 squared equals 144. So the first term can be written as 12x squared. The second term, 5 squared. So you can view 12x as a, 5 as b. So we get a minus b, which is 12x minus 5 times a plus b, 12x plus 12x plus 5. If the polynomial has three terms, then we have three cases to consider. First, we can try the perfect square formula. So we know it is a squared minus 2ab plus b squared. That equals a minus b squared. If here's plus, then here's plus. So let's look at example. (16x squared minus 88x plus 121). The first term can be written as 4x squared. The last term can be written as 11 squared. In order to apply this formula, we need to check if the middle term can be written as 2ab. So next minus 2a is 4x. b is 11. Let's check. 2 times 4x equals 8x. 8x times 11 equals 88x. Good. So they are equal. So then the outcome is a minus b squared, which is 4x minus 11 squared. If the polynomial is not perfect square, but it has 1 as the leading coefficient, say the general form is x squared plus bx plus c. In this case, we try to find two integers, p and q, such that p plus q equals the middle number b. P times Q equals the constant C. Then the given polynomial can be factored as x plus P, x plus Q. Let's see example. X squared plus x minus 132. Let's break up the constant term negative 132 to two numbers. So the product equals negative 132. The sum equals 1. We can try, say, 2, and then 66, but the sum is not good. Then we try another 11, and then the other factor should be 12. If we put 12 as positive, 11 is negative, the sum is 1. Good. So we can take negative 11 as P, 12 as Q. So the given polynomial can be written as x plus P, which is x minus 11, times x plus Q, which is x plus 12. If the given polynomial is not a perfect square and also the leading coefficient is not 1, say ax squared plus bx plus c. In this case, we try to find two integers again, such that p plus q equals the middle number b. P times Q this time equals the product of the leading coefficients and constant C, A times C. Then we can break up the middle term Bx as Px plus Qx. So Ax squared plus Px plus Qx plus C. Then we can find the greatest common factor for the first two terms and the second two terms, and then solve this problem. Let's look at example. 3x squared plus 11x plus 6. Let's break up the product of 3 and 6, which is 18, to two numbers. You can try 3 to 6, but the sum is not 11. Then you try 2 and 9. Yes, the sum is 11. Then we can express the middle term as 2x plus 9x plus 6. Now the greatest common factor for the first two terms is x. So we take it out. So x. And then 3x squared divided by x equals 3x. 2x divided by x equals 2. The greatest common factor for the last two terms is 3. So we take it out. 9x divided by 3 equals 3x. 6 divided by 3 equals 2. So we create a new common factor, 3x plus 2. We take it out. So 3x plus 2. So the leftover for the first term is x. The second term is 3 because the one gone. Let's try another example. Six x cubed minus 21x squared minus 12x. Although it is not a quadratic polynomial, but the greatest common factor of 6, negative 21, and negative 12 is 3. So we take it out. The greatest common factor for the variable parts x cubed, x squared, and x is x. So we take it out. So then 6x cubed divided by 3x equals 2x squared. Equals 2x squared. 21x squared divided by 3x equals 7x minus 12x divided by 3x equals 4. Now we break up the product of 2 and -4, which is -8, to two numbers again. We can try 1 and 8, but the sum is -7, so I put -8. So P equals 1, Q equals -8. So we can write the middle term -7x as x minus 8x minus 4. Now, the greatest common factor for the first two terms is x. So we take it out. So 2x squared divided by x equals 2x. X divided by x equals 1. The greatest common factor for the last two terms is -4. So -4. And then ax divided by 4 equals 2x. -4 divided by -4 equals 1. So we get a new common factor 2x plus 1. We can take it out. So 2x plus 1. Then the leftover of the first term would be x. The second term would be -4. Finally, if the polynomial have 4 or more terms, so the last case, 4 or more terms, then the technique is grouping. Let's see an example. X squared plus 6x plus 9 minus 4y squared. You can see the first return is actually a perfect square. So we group them. We can actually write as x squared. The third term is 3 squared. And the second term will be plus 2x and times 3. And then plus 3 squared. And minus the second term is 2y squared. So we get x plus 3 squared minus 2y squared. We can apply the difference of squares, a squared minus b squared. So equals a minus b times a plus b.